that in the box plot you get something like in the quartiles and a box with all the ranges from where it is starting and ending. In the quartiles it will be like sorry, in the violin it will be in the shape of a violin, and it will be like in the splitted form as per respective to the data, right? So for any data, let's say if we take the data from here for the box plot, it was there iris data is that, okay. So we can just write that SNS dot violin plot, and let's say we are plotting the same thing, the species what we plotted up there with the petal length. See, that's how it works, right? So you'll be getting exactly the thing. Then let's say draw a grid. Yes, the command to write the grid. Anyone? Quickly. Grid, not the grid. To make the stylings. Anyone who remember how to make stylings? Hmm?
Set style.
Set style. All right. Fine. Okay, so yesterday when you joined, we were doing some regression kind of things. How many of you understood that complete thing? If you haven't understood, let's know why we'll be doing it again. How many of you have like understood a bit of? Okay, fine,
No, sir.
no issues. Actually, for that, like going up with the data structures is important. No worry. Okay. Let's load a data set and explore this first of all. Um, like we had all the things with the pandas, right? You know a bit of pandas, something about the pandas, you know, right? So what we are going to do now, right? We are going to just revise up the things in a quick manner, right? Remember the data structures. What I said that there are three type of data structures when we were learning pandas. What I said, there are three kind of data structures. What are those three kinds? Anyone could answer? Hmm? Anyone remember? One was series, which were of 1D array. Another name, data frame. 2D. Third one, panel. Forgot. And it goes like, if we go for the dimensional, like for the popularity or like for the used cases, mostly used data frames over the series, over the panels. What are series? Anyone could answer like in one single line. Anyone could answer what are series? Quick guys, you are about to complete the module. What are series? Because I have written up there. It is 1D array. You can define it, right? It's basically a one-dimensional numpy ND array with access labels. Okay? Remember these things. Basically, these are like short thing to be discussed. It's important. This is called as series. Okay, remember every time, right? So I'll make you a quick review of whatever we did in this series. Right, you remember? Like we can create a series with numpy array or any dictionaries kind of thing. Oh, sorry. Right? We can make a series with by defining its own index. Right? Kind of things. We can define the series by the dictionary. Dictionary I am not going to do because right, we have did all these things, right? Just giving an overview basically. So we can define series with a random number and with a name. Right? This type, right? You can see the names, random series. So the parameters, whatever we write, be as same, right? For checking the name of a series, what we did, and giving all the basic things. shape, number of dimensions, minimum, maximum, sum, and some such functions. Where is a? This is x. Right? Okay. So there can be a lot of things for the series, right? Now coming up to the some good values like memory usage and bytes. Talking about memory usage. So here we use one function basically that is called as n bytes. So this gives you the information about the total bytes consumed by the elements of the array. Okay, how, let's say this is my x, or let's say this is a series of some 5 numbers, right? What are you getting? This series is having from 1 to, okay, 5 numbers will be like 6. Okay, so 1 2 3 4 5, right? Then the values you are getting in the print x, and then after this 40 is saying to be the size of all the elements, right? That this 40 bytes have been consumed by the elements of the array. Got it? Okay. Now uh, for getting the whole thing, right, for getting out the whole usage of the memory, we use something called as another function is there. It says to be memory usage basically. So it says about the total bytes consumed by the series. Okay, this was giving you only the array size. This will give you everything. Total bytes consumed by whatever it is coming up there. Okay, so let it be the same thing x, right? You just write as that. Memory usage is 168. You have parameters here. You can write up those things, right? Parameters in the sense that uh, you can write that print if you don't want to see the size of the index. Okay, so inside the memory usage, write the that you don't want the index size. So if you remove the index size, it will be 40. If you keep the index size, it will be there. Okay, that is how it works, right? Fine. Now you know, right? We did some kind of NAND numbers, NAND series, and all in the numpy. I make you remember. Remember that we made something kind of NAND. In the Simpy also we deal it with that. see there we have the second position NaN in the fifth position NaN, right? So now our important thing is to deal up with the NaN in the series. Okay. So how to deal up with the NaN? First of all, we'll be looking in this NaN. We have various functions like is NA, is null, not NA, not null, right? And drop NA, fill NA. A lot of things are there. We'll be discussing, right? So first we are going to discuss about is NA, and first let's look to the is NA, right? So how we deal up this thing. So this basically gives you that whether any series is null or not. Like you can get a help of this or see. So detect missing values for any array-like object. And this is fine. Okay. How? So how many NaN values are there in the X in the above? What we can see there are two NaN values. If I write print X dot is NA, so you'll get some Boolean result, discrete results, that is false true or false true. So you have to basically count the number of true coming up there, right? So instead of writing up this, if I write directly whatever the value comes dot the sum, this will tell you how many true objects are there exactly. This will not count false. This will count only the true. Okay, how many are there? Two. That's it. Then how many are not there? You can say detect non-NaN values. See, four is answer, right? Similar to this, we have is null and not null. That is mostly used basically. Apart from this NA, this is mostly used. These are the two things which are mostly used, right? Not null and null. This also does the same thing, right? If you write X is null, you'll get the same true, false, and all. Similar, you can also go for like Okay, similar to this, you can write with the not null event. That would work. Okay, this is all about the nulls and all, right? But what if we have some null values and we want to write some numbers in that places? So there we have to deal up with fill NA and drop NA. Two kind of things are there. Fill NA used for filling the NaN values. Drop NA is basically used for dropping of the values. That's it. So for whatever x we have NaN values, let's say that if we write C, is there any NaN values now? No. This the NaN values has been filled with this, right? But if you see the x, that is not still changed. So we are just printing that how it will look like if we fill it there. We are not storing. Okay, that's how it looks like after filling. And when you say x dot drop NA and just run this. So after dropping, the two NaN values will be dropped, right? And you'll be only getting the values what are there with the non-null things. Okay, got it. So there many a time what happens, we'll be using in place. I think yesterday also we used in place something, and students have doubt what is this in place works. What is the in place working basically? What is that true and false? Like if I'm writing in place equals false. What is there in the x? NaN and all the original one, right? And I'm dropping saying in place equals false. Still I'm getting the values. Drop NA has been done, right? But what if I say, let me make it down. If I say print true. Now what will happen? It will remove the NaN directly from the original array. See, the original array or the series will be directly removed, right? That NaN will be directly removed from there. It will return you NaN basically, right? But it will do its work. Its work is to remove the drop NA from the existing original one. If you don't want to remove it from the original one, you can just write drop NA. You can write in place false or don't write anything. That would work. But if you want to remove directly from the original one, you can use in place. And students have doubt regarding these things. I think you have been cleared with this. Any doubts with this in place?
No, sir.
Nice. Fine. So this is like what we deal about in the series, right? So going up with the data frames. The same will be also working on the data frames, right? That will also say working accordingly. So let's say we have names. What are data frames? Anyone could say? Right, so I'm creating a dictionary of marks. I'll say the name of the students as name, say physics to be physics, let's say chemistry, Alright, so let's say this is TF of marks, and I say my data or not using the data. What you can see, some 4 results A, B, C, D, and some of the data over there, like in the physics, chemistry, and mathematics, right? So in this data frames, the very important things, right? So starting up, like what are important, what are the important features? We'll talk about those things, right? So the very important, first of all, is to add a particular row in your data set. So to add something, let's say this is new row. We'll have to create the same things accordingly, the dictionary, or if even you can create it with the data frame. Okay. Now to add this, you have to append this row to the data frame. And how can you do this? Using df of marks will be equals to df underscore marks dot, how we append in the list? Append this new row, and you have to say that you don't want to keep the index as the same, so ignore index as the true. That's done. You'll find E over there as per the things, right? 78, 87, 98. But this is one such thing. Now to add a particular column, right? In that case, what you'll do? Let's say I'm going to add a new column, and I'm going to give some marks to it. Now what you have to do is you have to define what is your new column name. So let's say this is computer science CS. Let's write it. And this is equals to the new column values. Okay. See, a new column computer science has been given along with the like marks. Okay, these are the things like how we do it. Okay, so that's important. Okay, fine. Like if you don't want the uh, column, you can use delete, then your data frame name.
Excuse me, sir, I have a doubt.
Yes, anyone else trying to say something here?
Sir, how do we input the values in a row if we take the input from the user? Like for example, over here you have entered E7887 by yourself. If we are taking these input from the user, then how do we?
Okay, fine. See, what you can do is like, okay, fine. I got it. What you're saying. This physics.
So just take simple inputs and add that values to list, and
Yeah,
then
we can do
create
that.
a data frame with all these lists, and keep the original data frame with another data frame.
Yes, you can take simple input, store in the list, and then you can append it there.
Yes, sir.
That's the whole process. See if it works. I'm trying something new. Yep. Yep. I think these are the strings would not work up there. That is much better. Taking inputs and then adding up. Just trying to do that. But let's see if we could come up with this. Yep, it's nice. Going. So see, like what I have done is I have created a function. I have taken some 5 inputs and I have stored in the respective list. If I see my name, physics, and all, like what are stored in my list, I could see this all values over there. Okay, what you have to do is you have to create a dictionary again, like the same dictionary as you made it there. Like you want a row, right? So copy this up. So just copy all the things, right? Paste it there. So in the case of the name, just write the name. In case of physics, it would be PHY. In case of chemistry, CHE. For the mathematics, it's math. And one more is computer science. For this, you take CS and append it. So you got it, the results, right? So F, N, G, and like kind of things you have got right. So what you have to do is like what you can see there is 5, F, G, 8, 9, 8, something like that, right? You don't have to add the values exactly like this, right? Got it, my points. So what is there in this name? That is F and G. What is the difference between the name and what is the difference between the list of all of what we have created up here? What is the difference between this physics and name? Yes, anyone could say. Why we are getting exactly the things like we want is F, G, 8971 and like that. Why we are getting it like this? Hmm. Anyone could answer?
So because the name contains a list, not a single string.
So here also
Um,
name consists of
for
list.
this, we can create a new data frame with the new list, the name PHY, chemistry, math, and computer science, and then append the new data frame. Then concatenate the new data frame with the original data frame. Like df marks equals to uh,
Okay, 1 second.
we dot concatenate df marks and the new df.
Like this.
Yes, sir.
Yep. So you can take a data frame and then you can append it there, right? So first of all,
Yes, sir.
what you have to do is you have to create this in a data frame and then you can add it, right? So directly don't try to add up the things. So this is TF of new one, and you can say TF underscore sorry PD dot this data frame of this new row, right? And then you can append, like don't you have to write new row, you have to write the TF of new. It's being done, and you can see the thing, right? Okay, that's it how it's being done. Clear whose doubt it was?
Yes.
Nice doubt. Okay, fine. 1 minute. One minute, please. Yeah. So this is your data frame. Now let's say that if we want to drop this, how we can use? I have said the answer. If you want to delete this, how you are going to do? Yes. Answer quickly. Want to delete this? How you are going to do? Hmm. Quick. What I did. Write it now. Oh, okay. Yes, any answers? I have to read this row.
Okay, drop.
Hmm. Drop. Yeah. Then 5. Right? What happened? Done. Removing 5 will
Yes,
do
sir.
it there. But many a times, like if you want something from the excess to be dropped, so there are various features. Okay, drop duplicates, drop NA, and a lot of things are there. Like if I say, I give you one like random one. See, so this is ABCD. I'm having some data, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if I say to drop any column, if I want to drop a column C, how we can write? Yes. Answer. Wait, let me ask someone who will answer. Anshu, if I want to drop the C column, what should I write? Hmm. Okay. Next. Bhargavi, you say? What should be done? I want to drop the C column. Alright, C. You have to drop.
So may I?
Yeah.
So with access equals to 1.
Okay. Right? And
Yes, sir.
like if you want to drop a row, 2.
Then directly array dot drop in parentheses 2.
Hmm. Alright. Okay. So you can also drop a row by index, right? You can write it like RA dot drop, and then by writing the index, like if you want something from, let's say, 1 comma 2, could be right. 1 comma 2. What is that being dropped? Anyone could answer. What is
The first
exactly?
and second row.
See, this is your RA. So 1 and 2. Indexing first and the second row has been dropped, right? Alright, cool. It is clear to you, right? Moving up next, right? Okay. Now, coming up to our marks one, right? So we'll go it in later, like who have got the highest marks and all, we'll be seeing up in the later. Now we have locations in pandas called as LOC. Okay, locations we call that. Like now, what it does it access a group of rows and columns by their labels, by a Boolean array, we call, right? That is like pd.lock, pd.ilog, pd.add, pd.iat. Okay, these are the four things, important ones, right? So what's the working of lock, ilog, add, iat?
It defines the particular column.
We have seen, I think, right? Lock, ilog.
Yes, sir.
So how it works, like let's say that if in the same data set, like RA, okay. So if I say I want to index, I want to see if I have RA, I have three columns, three rows over four columns. Okay. Now I want to see that what is there stored in the third column, right? What is there stored in the third column? Or let's say I bring the DF marks. Right, so accessing the third column of our DF marks, how we can do? Just by writing the DF marks, and then you have what you have to see that what is the third column, right? So can you directly write columns? And third columns will be the second one. Chemistry is the third column, right? So what you can do is this is column basically. You can just write DF like in the brackets chemistry, and you'll get a series of all the datas, right? So remember, like here when you have dropped, don't forget to write in case. Right? So we have 89, 76, 85, 46, 87, 89, and 86 in the chemistry harmony. The second option is like you can directly write df of marks dot the chemistry. We'll be getting the same things. Okay. This was making one column in a series. That's an easy thing. Now, if you have been asked to see the marks of row number 3, or like to see the marks of D, okay, how much D have scored in mathematics? Question. The question. Tell me the answers, what I can use. What are the ways? How many ways you see? How can we get the answers?
Two.
Alright, okay. First I have to locate that. B. Where is this B? Mathematics 83. How to get this answer? So here we are going to use all these things. All this, right? How? See, like So when you have a large data set, this is only a list of like seven data basically, right? When we like in further time, we are going to upcoming days, we are going to deal up with the data set which could have even more than 1,000, 5,000, 10,000, 30,000 even uh, rows, right? So in that case, we cannot just print all the rows and then can we check up for all the things? No. So in that case, what we have to do is we have to locate the particular thing for what we are searching. So we are searching for D, right? We are searching for D. Okay, but this lock depends on the index name also, right? Okay, so what you can do is you can using the lock. I can just write that lock. So if I say dot lock and then I say D, what is that? Key error. Why? Because this is not a index value, right? What is the index? What is the index? Index are 0, 1, 2, 3 and all, right? So you don't have any index particularly for this. The using lock will not help you up much better like in this case, right? Got it, my points. So what you can do is you can go for finding it according to the index number. So this is 3. So I can say log of 3. Locate the 3. Third row. So this is the third row of D and we are getting the data like here we have got all the data, but here we are only getting the data for D, uh, like the physics, chemistry, mathematics and all. And here also if you want for the mathematics, you can write in the D, find the mathematics data and you can go with that. See, 83. Got it? So DF of 3 and you search for the mathematics, you'll get the data. Otherwise, what you can do is, so many a times what happens, as I said, that always this 1 to 3 is not going to be your index. Many a times it will be changed. So you can't use every time the lock method for only the index. So for index, we have a specific function that is index locations, iloc. So here you can't use any names. Here you only have to use the index location. Okay. Let me cut this. I'll write it here. So you've got the using the lock and iloc, you get separately the things accordingly, right? Okay, this is one such feature. Now, what you found, if I am writing df underscore of marks dot log of 3, what I am getting? A series, right? Name 3 series I am getting up. But if I don't want the series, what should I do? I should make a double bracket here to see the pivot table of the third row only. From here, even if I don't write all these things, I can see okay, the computer science was there 83. Okay, like that's it. Okay, similar BF of marks iloc 3. Okay, fine. That is how it works. Now, the second thing now we are going to see. Now, if you
So
want,
what
yeah,
is the difference
anyone,
between lock and unlock?
someone was speaking something.
I did not get the difference between lock and unlock.
Difference between lock and iloc. I knew. Okay. All right. Hmm. You didn't get the difference between lock and iloc. Okay. So this is your DF. Lock and iloc you haven't got. Alright, fine. Let's load a dataset. I'll give you a description from there. So now, like loading it, but it not will help me. Let's make a data frame. So we have a data frame of marks, right? Let's make a new data frame of marks. Okay, and I say my index to be name. Name. I think this will help you.
Okay, sir, I got it. Lock is based on the names of the rows and columns, and
One
iLock
second, your
is
voice
based
is
on the
very
input.
less. Yes, what are you saying?
Sir, I said that it's based on the name of the rows and rows and columns,
Mm-hmm.
and iLock is based on the index value.
Mm-hmm. Yeah,
Yes.
that is how it is being made exactly. So the columns, let's see, shape is 4 by 4, indices apply 0 by 4. What is this? Marks, okay. TF is okay, yeah. 1, 2, 3, 4. And one name values to be there, index has index. Will it work now? Yep. Okay. So see, now this is A, B, C, and D. Okay, and using the locate, what I was saying, that what you can do is you can write locate this time, and you can just say locate the value of D. That's it. Done. You'll be getting the things. Got it? Or otherwise, you can just write df dot locate of D. Only watching for the mathematics, you can write in the D you want only for the mathematics. That is D. I've got 83 named in the mathematics column, integer 64. Lot can be done. Okay, clear to you, right? I hope. Okay, coming next, right? So I think lock and ilock is clear. Now going up with at and iat. What is this all, right? Now let's say, sorry. Now, uh, let's say you want to get a specified row or a column pair. Okay, want to get a specified row or a column pair, let's say. Now I want to find exactly the same question is there, right? Using the iat I'm going to use. So D in mathematics, right? In the mathematics, in the D, using the DF of marks, right? Don't go with this. We are going with this DF of marks. So using D in the third column, mathematics in the 0, 1, 2, 3. Third and third, right? Everything is 3 and 3. What you can do is the DF underscore of marks dot at. So in the third column and the third row. Uh, oh, sorry. 83. Okay. The third column, the third row mathematics column 83. Using IAT, third column, third row value 83. I have clear. Any doubts here? So what is there at the third row in the mathematics column, and what is there at the third row and the third column using index values? Got it? You can do this with using the lock also. You can go by using like marks and start like when you use ilocate or like uh, you can write using ilocate, you can write iloc of this third, and you can go for at of I think it's 3. Okay, sorry, you have to use I at, yeah, 83, right? Similarly, you can write tf of marks dot locate v3 sorry, and then at of mathematics. When you are working with a df event, sorry, okay, I hope various methods I have given to you, like you can find with a lot of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 methods. There are more, right? You can build your own ones. So you can use these features, these methods to find out the values accordingly. One more thing is there in the pandas, right? The important one is axis. Now, axis, what define your axis? Axis means the values of the rows and the columns. Rows and the columns, specifically axis1 and axis2, what are there? You will be getting up the same things, right? So marks dot axis. So index is having an integer 64 and the values are 0, 1, 2, 3, 4, 5, 6, 7. Index is there in the second one, right? The one, the name, and all this. Data type is object, and that's how it is being defined, right? So for any data set, what you can do is finding up the sums and all for like all the values, right? So if I say what is the overall marks of the student, if we want to calculate the percentage, how we are going to calculate 1, 2, 3, 4, right? Percentage for B. We go by calculating the percentage of B with this data set, let's say, right? With this, calculate the percentage of A, B, C, and D out of 300. How you are going to calculate? Yes, answer quick. Anyone? What you can use?
The location method to get the marks and then calculate it.
One, two, and three, like this. How? Mhm. Last question, yeah? So quick answer, quick. Yes? How we can do? What I am thinking is that we can, for like, uh, there can be various ways, but I am thinking that if I remove this name column, I'll only get physics, chemistry, and mathematics. Or PCM. Okay, fine. Hmm. 3 marks are there, right? Okay. 0, 1, 2, 3. Range of 4. 0, 1, 3. Anyone got any methods? I'm using something different for now. I have a simpler method, but using something complexities. Let's see if it would make it. 0, 1, 2 would be there. Let's go with the 4. No. This does not work. Uh, I think we can apply this. Or in the DF, you can find, you can use the drop.
Sir,
Hmm.
so can we use can we just add all the numbers in a list and then calculate its average?
1 second. Got it. He. I was using this. Yeah, you can do. Yeah, what you were saying? Adding all the numbers in a list, right? 68, 89, and all, and then
And
by
then just
making the
calculate
percentage.
the average.
Yes, I think more easy is like if you drop the name column and then find the sum according to their, like A has got 253, B has got 200, C has got 246, D has got 218. So no thing of like making a list and then adding up. I think it's easy. Like you can go with what you are comfortable with. Name and then okay, this is nice. So I've got the marks right directly. Yeah, you can now easily calculate the percentage. Now, what more shortcut can we apply? Anyone who thought this answer? So you have thought of making in a list and then finding out the percentage accordingly. That's nice. So sum divided by 100. Sorry, 300. Oh God, we have got the percentage. Yes. This is one. See, I've got the percentages. Right, so no making of less, nothing. So A have got 84%, B have 66%, and thought the maximum 84.33% is the maximum. A has got the sorry maximum marks. We'll go in later onwards with more detail tomorrow, right? Is this easy or making a list of kind of thing is easy? What do you think? I think this is for me. This is easy. I'm very lazy.
This one.
What do you think, guys? Anyone thinking of any much better answer? I thought this would be better, right? What I could do is uh, I can drop this name column, right? Not deleting and just dropping this. I can drop this name column and then I can add all the values directly. Why to make it a list and then add up the things? If I say that df dot sum, what I'm getting in physics, sum is 309, chemistry 296, in name it is ABCD, in mathematics it is 312. So what exactly I'm getting up? I'm getting the sum of three, like in the column wise. The excess is equals to 0. So that is you are getting up there for the column wise.
So if we do x is equals to 1,
Then we go with row wise. What I have did. See here,
okay.
right? So we'll go to find the sum according to the 1. Row wise addition. You're getting, see, A253 and this all. So after doing this, what I did, right? After like dropping this, what I did is I divided this by 300. It's very easy. 300, giving you some percentages, right? And then I'm multiplying it by 100, and then I'm getting the percentages, and then I'm making it in the round off of 2. Sorry, not like this, but just making a round of all the things, right? You can write inside the round or 84.33% and all like such things, right? So this is what I have done basically. So you can use this feature also. If you don't drop and all these things, if you want to find only the sum, you can directly go. There can be separatable methods. There is no such thing that you should only use this and like that, right? So you can use any of the things. Oh, it has gone upwards. Why? Come downwards. Oh, yep. Yep. So that is all like working. Okay. So you can find the maximum, minimum, and all such things accordingly to that. So I think this is easy, right? To find the sum of all the things and then multiplying it and then getting the percentages. And you can find the max, minimum, and all. You can sort the values. You can get it the things. Okay. Also, you can do like who has scored much in the physics, who has scored much in the mathematics, who has scored the maximum in like. So what you can do is tf dot max of any particular subject. Take any particular subject. So max of x is 1. So what I'm getting 96, 76, 90, 87, and 80. Let's print the df first here. So what you are getting 96 maximum is 96, then 76, then 87, then 89, right? So d maximum marks is 89. A has got the maximum values basically. 96 is the very highest marks in total things. Okay, so where the D has got like 89, what you can do is you can find the DF equals to you are getting for the D, right? So DF dot D, sorry, locate DF dot locate D equals 89. So you get in the physics. Okay, okay. So one true is there, but where you can find it in the physics, right? So there are a lot of things, guys, to do in the physics here. So a lot of things can be done. So any more like suggestions for finding the percentage? I got this method. Any more suggestions? I could also learn something new. Okay, you try to find something new from this. Okay, so tomorrow we are going to deal up with the data sets and will be start doing our EDA, right? Exploratory data analysis, and then by making models. Okay, I think it's clear. A lot of things has been clear from the pandas, I hope, right?